Welcome to this video where I will talk about Robert Gagne's Conditions of Learning. In his book entitled Conditions of Learning, he talked about types of learning which describe desired goals of instruction, events of instruction which describes goal-relevant initial learner states, and conditions of learning which describe the transition process and instructional conditions that promote the transition. Gagne presented 8 types of learning in the first edition, in a strict hierarchical relationship. He carefully referenced researchers that had examined these 8 types of learning. In the fourth edition of his book, he identified distinctly different categories within the domain of intellectual skills. These are discriminations, concepts, rules, and higher-order rules or domain-specific problem solving. He proposed that these knowledge types are in a prerequisite vertical transfer relationship. The types of learning in the fourth edition are: first, intellectual skills; second, cognitive strategies; third, verbal information; fourth, motor skills; and last is attitudes. Gagne and Glaser included an excellent summary of hypothesized differential learning conditions for the types of learning. Their suggestion that for each category or subcategory of learning capability to be acquired, certain conditions must be met. It should be noted that in Gagne's detailing of the conditions of each type of learning, the major condition that he details is prerequisite knowledge. Gagne also introduced events of instruction, the description of the required terminal performance and provision of guidance of thinking. Application during lesson design often sees many of these events combined or overlaid, depending on the content and learner levels. When applied in a digital environment, some of the events are grouped to best support continuity and flow. Common activity in a first-year engineering mechanics course about the lesson regarding relationships of position, velocity, and acceleration. First to third events of instruction could be the multimedia product with moving objects such as cars or falling objects with questions relating to how and why. And once the why is introduced, connect the student objectives to student pre-knowledge of the concepts from their math and physics courses. Fourth and fifth events could be in many forms including graphical, textual, or visual models. 6 to 8 events can be presented using laboratory simulation websites. Mathematical relationship may be explored using Excel, where students create their own relational models. Last event, it would consist of having the students apply their new analysis skills to those complex real-world scenarios. Events arranged in a hierarchical manner help educators to decide that subordinate skills should be taught before teaching higher learning types and to break a complex task into component skills. According to the study of Yusuf in 2013, the students who are enrolled in chemistry got higher performance and decreased their anxiety level during their lesson and assessment on balancing equation when they use the 9 events of instruction compared when they use the lecture method, the oldest way of teaching based on idealism. Main factors are the presentation of the concepts from simple to complex ones and taking careful consideration of the prerequisite knowledge of the students. Lastly, the conditions of learning to be met per learning capability serve as a guideline for science educators in providing stimulus for the recall of prior knowledge and opportunities for enhanced retention and transfer of knowledge.